Good morning, everybody. Good morning. This is Engineer Suraj Singh speaking from Bharat, India. On this day, October 16, 2021, Saturday, quality, safety, health, and environment, as usual, and we stick ourselves to quality issues and also quality system in construction of contracts. These certificates you have seen do have meaning only if we have production of quality everywhere. Quality, which is essence of life, is too significant to be considered by everybody, whether you are professional or not. You are not professional. It's meant for everyone. Civil field engineering, life engineers, civil field engineering, life and engineers are linked because in engineering links to life and links to life means development links to engineers, and development should be quality oriented and there should be structure of that quality, and of course safety, health and environment have to run together. Therefore, in construction, which is based on designs, based on methods, and of course in sphere of contracts, organizations, communication and coordination, certain topics these are included on title are of course relevant in every sphere. That's why I have selected as such that at least certain points must be covered. We can write our life is important, and if life is important means engineering is important, and if engineering is important means quality is important, and if quality is important means then everything that has to be done in construction, in development, that is designs and construction, must have certain rates behind, certain backing behind, and that backing is we have to do everything according to its requirement. We cannot just do our way. A system that is taught or that is understood in our whole education, whole training has to be complied with, and which can be done only through communication and coordination methods. You know, I have discussed it many times, and of course, I also understand that one should not feel bored. But do you think if you talk something logical, or if you talk something reasonable, something related to life, and something related to development, something related to engineering, and to improve in overall life standards of people, you can say quality of life, that one. If quality of life is improved or it is raised to whatever expected level, it can give you something. It can be called some comparative standard. Standards are created, standards are managed or adopted. Now, what I am stating here is not standards. I am stating here is basic requirement. We can have standards only if we can have base. And if you don't formulate any base, we cannot set any standard. It's like our body. We can say anything, but if body has no function, if there is no system, body cannot survive if there is no system. There is a complete system of our body. There is complete system in every machine. Only then machine can function. You can take any machine, whatever machine, you can take flight, plane, aircraft, you can take train, you can take car, you can take a small toy even. Some unit or whatever reference we consider has got certain mechanism to work, our body to say. What we are talking here is mechanism, and that mechanism is composed of many components. and all those components must work in unison, must work duly coordinated, must converse with each other in its mechanical way, and then we can say it works. I don't want to relate other issues, but I can say that there should be no panic first of all. Panic does not work in engineering, panic does not work in development, panic does not work in quality. We have to understand what is quality, we have to understand what is patience, we have to understand what is analytical world, what is safety, what is quality, what we should do, what is engineering, what are engineers, and we can see that all that we have to understand practically, not just in thoughts. Thoughts have no meaning when practical starts, when time starts, when cost starts, when risk starts, when reliability starts. Analysis are done, synthesis are done, thinking and concentrations are applied, powers are applied, and powers are achieved. And you can say all these are very basics in engineering, and engineering which gives us something, we don't give anything to engineering. Of course, engineers are involved, they study a lot, they work a lot. They work a lot or they don't work, that is different issue, but they do a lot, they should do a lot. They are developers, they are agents of change, and they convert deserts to something we can call a city, industry, residential, whatever. Well, I don't want to move around unnecessarily because unnecessary movement has no meaning, and I just come to point about quality system. Quality is a system that is generated for development, that has been generated for world over, for construction, for mechanical, for electrical, for civil, combination of everything. It doesn't define combination, but it defines how a system should work. That system should be real one. It should give some result. Of course, it is our own creation. It's not something that evolves itself. System must be well defined. It should be based on experience. It should be based on technical understanding, technological understanding. It should be understood by everyone. It should not be difficult, in fact. It should be easy and well communicative. It should tell everybody what is being done. I don't want system to be written in such a way that you have to open dictionary all time. No, that's not right way. We use language only. It doesn't mean that we have to expert in that language, but we should know enough that is well communicative. It should be well communicative. That's enough. We have communicative system. We can coordinate with each clause in system or inter systems we can understand. It's something different. You can say we can say there were systems before also, but maybe those were not written, not documented, and now documentation has been done, but that is also amendable. It depends on requirements, it depends on what do we want, what is intention. Just like you can say we do designs in engineering, and all designs are different. We design a small building, very small, say one room. We design a different building which has multi-story or having 3 or 4 stories and many rooms, and we also design towers. Similarly, we design some other mechanical machine, we can design something else, electrical appliances, electrical equipment. Just like every engineer who has that field designs something, involvement of design, and then involvement in construction or manufacturing, it is linked like that. Every design is different, but basics are same. Basic, you can say basic theory, basic formula, or basic procedure is same. Steps may be different. Properties of material is same. This cannot be changed because it has been tested. We can use whatever material we have to, and that material functions accordingly. If material doesn't function accordingly, then we cannot generalize properties of that material. So designs in fact are well defined. Only difference is that we have to take steps in that in whatever way possible, and it is for all development. Properties have been defined, sticks have been defined, how it works has been defined. Now how designer collects information from every step, from every property, and how much it is used, to what efficiency we take that into our calculations, it depends on our successful or unsuccessful design. Sometimes designs are done very well, and these should be transformed to physical being also with same, you can say, concentration, same hope, with an expectation that our construction should be excellent. Our point is, ultimate target is delivered product. Ultimate target is end product. What end product we get, how much serious that product is, what to what level, to what extent it can be used in best possible manner, so that we get best advantage from that product. That is whole destiny, whole target. That is, you can say, destiny of what we do, from its conception stage, through its construction stage, and also before that design stage, to its construction stage, and to its use stage. All these are connected together. These are connected together. Feasibility is there and links are there. This cannot be separated. Even if we want to separate, there is no way. Yes, workings can be separate. Every location can be separate, but links are same. So we can say whatever product we get in market has a long process. It's a train of processes. It's a train of designs. We have to keep that factor in mind. No activity works in isolation. And that we understand from quality system, that it is an integrated approach, unified approach, that it may take time, there can be gap, but whole are connected together. This is where we can say quality system, you can call it, or you can call it working system, or you may call it system. For me, it doesn't matter as far as I understand what I have to do. I have seen that time also when existed no quality system, but quality existed, system existed, and works were done. Now system is professionally existing. It has certain structure, and that structure is to be complied with, and that structure keeps on changing from one point of time to other point of time. We are now concentrating on contracting. Contracting, which is very easily defined in a very common way, not in a legal way, I can say. Contracting means when two persons agree for something, for some action to be done, some work to be done, in lieu of some consideration, and consideration means some payment. That is simply called a contract. Contract means, it doesn't mean you should have a brief understanding of contract is this. Two parties work together for something, for some target, and of course some consideration must be there. It's called a contract. then you can say time is given there, or you can say many other conditions are given that we go further. But it doesn't matter that contract should be big one. Contract can be very small. It can be for 1 hour, it can be for 2 hours. You drive, you take service of a bus from public transport, and you buy a ticket to go to some destination. That ticket itself is a contract. You take railway journey, that itself is a contract. You take a flight, that itself is a contract. So contract can be analyzed like that. You sometimes do not even know that you are on contract and you are traveling. You are taking a service, and that's also a contract. But here we are talking of something durable, something that doesn't limit to minutes or hours or days. It limits to many, many years. And that's what construction contracts are. Because construction cannot be done in one day. Even if it is a small room, you give a contract, maybe say 4 meter by 4 meter room you have to construct. It takes time. It cannot be done in one day or 2 days. It shall take its own time. Maybe 2 months, 1 month, 3 months, depending on so many factors, so many points. For that contract is required. Why it is required? Because I am not capable of doing myself that construction. If I do myself, then I can say, okay, I am doing myself, but still I would require materials, I would require workforce, I would require some mechanical equipment and some technology to construct that room. So if I don't give it on contract, then I have to procure material. Material procurement itself is a way to have contracts, supply contracts. I have to select materials myself. I have to go to market, or market has to come to me whatever way. I have to select materials and buy them. And buying them means I give money, and those people who are vendors and suppliers, they supply to me at my home or site that required quantity of material. So even then I wanted to avoid contract. I still shall be forced to enter into supply contracts. Or then I have to hire some workers, which may be only some specialist vendors are there, or I have to see myself these workers from market. Whatever I have to hire some work element contractor, means those who are available in market for such work contracts. This means if not prime contract I am going to work on, I have to depend on supplies contract and workers contract. So whatever way I have to go, I cannot avoid that. We used to call this sometimes when we used to work in companies and departments, government. The government sometimes try to work itself. That is called departmental activities. And I think personnel of government, engineers and others were not very interested in that because of so much headache in handling such projects, and cost justification, time justification, and so many technical requirements had to be met. So easiest way was for those engineers who headed that department or government's bodies. They ultimately concluded that it's better to go on contract just to unnecessarily take headaches and avoid responsibilities. It was easiest way that go for contracts and let us only supervise and administer. This means they avoided responsibility. It doesn't matter you do yourself or you do in department, but somebody would do. If you are not going to do, then contract to personal would do. Contract to personal, also engineers. Means without engineers employment, without engineers being on roll, no contracting company can survive. There was a time people didn't know about that. The contract was just anyone who can do this construction, but later on there were amendments, and now in contracts it's mandatory that contracting organization must have a specialist construction engineers within its organization. Otherwise there is no question that you shall be registered as a contractor in whatever government body or other organizations which do not relate to government. professional organizations. This means it may be contracting, it may be design, or it may be whatever specialist section of engineering. There can be no work done if engineers do not work. If engineers have got some specific profile, then it's responsibility of engineering community itself to be serious about that. Everybody knows that life cannot move without engineering. Life cannot move. I'm not talking of civil engineering alone, I'm talking of complete engineering. All branches of engineering which directly relate to life. From civil engineering to agricultural engineering, from mechanical engineering to electrical engineering, and from security engineering to surveillance engineering, to, you can say, every engineering counts in life. Some counts on higher profile, some counts on lower profile, but engineering counts. We cannot go oppose this. This is a fact we have to agree. And when engineering counts for every person. Every person. If road is clean or not clean, it's a question of maintenance engineering, environment engineering. Your area is tidy or untidy, that's also a point of environment engineering. There is dust control or no, that's also a part of environment engineering. Same way you have sewer line or no sewer line, water line or no water line, open drain system or some other system. There's no rainwater system, there's this system, that system, there's no firefighting system or there is firefighting system. Life is moving sometimes without systems and sometimes with organized systems. Fire extinguishing, firefighting, fire prevention, public safety, all that are included in world of engineering. How this is operated, that is different. How much political interference does work there, that's also important. And how freely our engineering community think, that's one point. Purpose of engineering is that engineering should benefit everyone. That's purpose of engineering. It's not that you have to benefit some specific people. And engineering also doesn't mean that you should point to profit percentage. That's not exact job. That's one part of engineering, not entire part of engineering. Engineering means development. Engineering means optimum use of natural materials. Engineering means optimum use of our workers. Engineering means best efficiency use from mechanical equipment or machines for development. Engineering cannot be confined to just profit and loss. That is commercial part of engineering. That's not exactly technical part of engineering. And that commercial part of engineering cannot also be generalized. Because engineering is intellectualism. If you take another meaning of engineering, it is called intellectualism, practical intellectualism, applied intellectualism, intellectualism that creates something or that destroys something. What I say, engineering can create as well as it can destroy. It can destroy if something, you can say, when you go opposite development, you want to kill world by use of nuclear science, or also you can build world by nuclear science. Both ways are there. Engineering is very difficult. In fact, it's very difficult if you truly analyze it. And it's very easy when you take it to be very easy. It's expensive. When you consider engineering to be very easy, it's too expensive. Expensive in terms of vistas, not in terms of money I am talking. Technology has expanded so much that it is very difficult to coordinate in technologies itself. You can see computer world, IT we call it software world. So many websites are there, so many languages are there, so many, you can say, we'll find sometimes problem in these websites itself. Technological update, this update, that update, I think you got every time update and update and update. I don't understand why you want to update every time, but this is technology. Well, I'm not IT engineer, so I'm not going to unnecessarily argue with that, but it causes some inconvenience, that is true. This is no, there's nothing permanent in that, but what I'm talking is permanent work, because engineer's delivery is permanent. If temporary delivery is made, I don't call it engineering. If you deliver something to you, then you can say this is just temp service delivery, you can say. Some product that can be used only for a few months or few years, and then it's no meaning. I cannot say that is a good engineering, because natural materials are used and you cannot destroy natural materials like this. You can say this plastic pollution. It's a pollution of different kind which can't be conducted, which can't be handled, but it's nothing new, means everybody knew this, it will happen from its initial stages when nobody cared. And because economy came into mind and it worked for us and economy pressed everyone, economy causes problem also because it doesn't care for facts. Politicians are linked to economy and they don't bother about all these. All politicians from around the world, I can say, not in one country or two countries, everyone. Still today, despite COVID-19 causing problems all over the world, politicians are interested only in economics. They are not interested in lives of people. Fake news, bad news, concealing news, this is trend now. It has been about 2 years since COVID-19 impacted. Many people have lost lives, millions of people, but we still are interested in economy. We are not very well interested in health. Only wipeout is that just the curtain of vaccination and all this, or wrong tests. Every day you get news, unfortunately. No country has now capacity to speak truth. But engineering is engineering, it can't survive without truth. If you want to find truth in engineering, you are looking for truth somewhere world. Where does truth lie? Where is it located? We can say truth is located in engineering. I am not saying this because I am from engineering field. It is science. It's science that applies to whole world. Engineering applies to whole world, even you may not relate to that. It relates to you. You use engineering product. Every building is engineering product. Even you can say food that we eat, that is engineering product because it comes from applications of agriculture engineering, and of course natural inputs are there. We have to consider engineering in that spirit, that soul. That engineering is a part of our life, it's a part of our soul. If I can't enjoy engineering not in any way I have to apply engineering because I am using it. If I am using a building, then I hope and I expect that this building has been done very well. But when we construct it, at that time we don't realize this fact. Unfortunate that engineers too lack in this way. Means something you have to do means you have to do, that's okay, but it has to be done in best possible manner, that's required. And that's where quality points comes into our consideration, our assumptions, our platforms, as well as safety platform also is created or available. If everybody is safe, that is first requirement, everybody working is safe. Health is safe, environment is safe. And then we can say product. Product that is being created must be safe. If that product is not safe, then safety has got no meaning. Product safety means product should be durable, it should be functionable, it should give purpose for which it was designed, and if it doesn't serve that purpose, then it's confusion, means what we spent for, what we did, yes, it is serving better, then that's fine. And then when we do engineering, it is something, it's not unknown. We know what we are doing. We know what formula we are using, what procedure we are using. As far as its design stage is concerned, there's no problem in that. Only problem is experience of designers. Means there should be pragmatism in design, not just depending on formula or software. We should understanding of what we are going to do. How far can it be practical and how far can it be done convenience and how long it can move. Those factors must be kept into consideration. Economy is one requirement, but economy is not an only requirement. We cannot keep every time economy and say I have to design with minimum quantity. That's not way. We know some part of economy, some part of technical requirement, and keeping quality mind, and then you can say combination of all this and whatever else is expected or a kind of innovation that we can do. Only then we can do better designs. Design is not easy, we know, just like construction is not easy. Both are difficult fields. There can be many designs for one work, but which is best one, why it is best one, that is what designer should understand itself. Somebody thinks, oh, I can do little size, small size of column, big size will cost more. If you keep that only point in mind, you cannot be a successful engineer. Because we have to keep in mind ease of construction, efficiency of construction, what design we do, it should not cause any problem on site or it should not cause any problem in manufacturing. People should get something which has been done with convenience and which is durable, which is defectless. Defects won't work, and defects happen because of lack of communication, lack of coordination, lack of information. And we know what designer thought was unable to express and what construction guy thought isn't able to extract the information from design documents. That's where problem lies. Expressions are missed. Designer and worker who sits on site both can't work together at same time because timings are different. Designs which were done long back is going to be implemented after collapse of many months or years. So there can be no way that designer and person responsible for construction sit together. There can be different people, different personnel, different engineers at different times. So point comes in the why and how can we rely upon that. How and why we can rely upon that is only one answer, and that answer is documents. That answer is to what extent we can get information from these documents, and that is design documents. If we cannot get information from design documents, this clearly indicates that that designer did not give complete information in terms of expression but only in terms of some drawings, and that's where fault lies in. See, whatever is in mind should be brought in certain definitive terms on some papers. It should be clear what designer kept in view, and that is where we can say quality system pushes all this. Quality system has given us now in 2015, that is ISO 9001, many sections in structure, clause 1 to clause 10, and they are having various specifications to be written. I mean to say, clause 1, what does it say? Clause 2, like that. Where is planning? Where is design? Where is reference? And where is scope? What is required? What is not required? All that we have to do. That point in this system we had been discussing. Other we can just forget, maybe it's better to repeat sometimes. As you can say, in clause 1 we had scope, which is very clear. Contract has always some scope. Then clause 2 says there are normative references, whatever are these, we have to better write it or explain them. Then we can say terms and definitions on this system. what this system is, terms and definitions, so that everybody can understand on what we are going to rely. Then there is a context of organization, means what this organization where I work is, or what my organization is, how does it work, that text is there. Then we can say after that is clause number 5, which is also in that direction. Leadership, actually leadership can be clause 0 also, but no problem, leadership exists because organization exists and that leader is responsible for it. And there is no one leader in everybody is a leader, in fact, and everybody is a follower, so there is no follower column in this. Everyone is leader, clause 5. So clause 6 is then planning, how planning is done. Plan means everything, then just like a construction, a design, or you can say planning is in between, and planning is for every activity. Planning, that is clause 6. We have after that clause 7, and that is support. What support do we get from whom? Support of every source, every resource, technical resource, non-technical resource, awareness, and communication and documented information that we are discussing about. Then we have 8, and that is of course operation. We considered in this case operations for contracting. What operations were there are considered. Operations means from complete construction world, contracting, doing it both. And then we had here after this clause of operations, we have performance evaluation, that you can say we can talk together operations and performance evaluation. This performance evaluation, which includes monitoring, measurement, analysis and evaluation, internal audit, management review or organizational review, in which case we consider operations of organization required to decide about internal audit to ensure compliance of management system, and final review by the system to ensure its compliance and whether or not system works suitably, adequately and efficiently. We now talked of operations before, and you can say operations can be talked in a way that you can write even books or thesis on operations, and we can then review all that. We talked about process of bidding and of course process of negotiations. Both are integrated together, that's why we call them operation, and these operations are not ordinary one. These include many aspects of contracting. As we said, it is construction contract. It would be VPC also, that we will talk of later, but now we're talking of construction contracts. Construction is such significant. Once it is done, it cannot be redone. It cannot be redrawn. It cannot be withdrawn, because it has been done for decades to come. We cannot change once we do it. It's not temporary work, and it's perfectly permanent work. In comparison, than temporary works. Construction means lot and lot. We spend billions and billions and billions units on constructions. Statistics state 60 to 70% of budget of every nation is moved to construction in whatever field, whatever departments, or whatever parts of economy it is. where construction is done. And construction is done in every field of life. Civics, it may be army, it may be road development, it may be some other development. Whole development is based on certain kinds of construction. We are talking here buildings construction, RCC buildings. And we talked about beds. RCC, that is called reinforced concrete or cement concrete, is not small item. It's very difficult item in a way you design it and then you construct it. It's not that easy. It's time consuming, it's cost consuming, it's quality required consuming, it's safety required area. And years are consumed, millions of workers are consumed, their actions are consumed, materials are consumed, are included permanently on these construction activities. We cannot simply undervalue this, because future development, future efficiency lies in this construction world related activities. I am saying construction world because it's a different kind of world. You have higher responsibility, higher movement. It's not like an ordinary office. You come early morning, work for a few hours, and then say bye bye, I'm going. This is not that. Construction means a field work, a work which cannot be responded, but response comes only from its production, its rate of progress. How we move, how much we should have moved, where is fault, where is no fault, do we exit, do we get quality or we don't get quality, do we get performance or we don't get performance. You can say it's a kind of a word which cannot be defined in the ordinary way. We use all resources at one place, all resources. And resources can be human resource, material resource, design resource, technical resource, skills, whatever. They learn on construction and they do on construction. It's such a world which we can call as a training center as well as working center. It's industry as well as manufacturing unit. Because nothing can go out of that location, everything will stay there. It's a combination, focus of all resources. And it's such a work where it looks sometimes we work very fast, but we are not very fast. Temporary work is done there, preparatory work is done there, permanent work is done there, interactions are done there, arguments are conducted, references are taken over, planning is conducted, evaluation is conducted, performance is conducted, references are conducted, scope is conducted. What we talk in this quality structure, there is nothing that we cannot conduct there. As is a performance evaluation, we said all clauses as planning, it's all clauses there, terms and definitions. Likewise, we can say leadership means then review. There is nothing that we don't conduct on construction. Every activity is conductable and conducted, carried out. So you can say this structure format is actually construction format. Sequence can be different, but contents are same. We can say if you want to immerse in life somewhere, construction is there. Without construction, you cannot do anything and that's why I say this is field engineering. In field we engineer something for people, for world. How much we perform, that is something for which we did everything. And we say performance evaluation. We perform and that is evaluated, that is given some measurement, some unit. We have done this, we have achieved this. Achievement is doesn't mean here we do means achievement of what was required. When we say achieve means comparative achievement, it's not innovation but it was demanded, it was planned, it was expected. That level of performance we review, we evaluate, that we had to design ourselves, we had to understand ourselves, and we have to do ourselves. It's a kind of different world. When we contemplate on this, we'll say, always change. Every day there is change on works. Every day some addition. You will not find every day same, every day is different. You can't say 3 days back this was the status of this work and today it is same status, except there is exceptional events, work is stopped or something else happens, that is different. But every day some addition has been done. Some kind of addition by temporary activity, by permanent activity, by preparatory activity or by whatever else. Every day we find some change. This means construction keeps on changing every day. Design keeps on changing every day when we are in process of designs. But once it is compiled, it is approved for construction, and that approval means you can start doing that work. We discussed about bidding. Bidding means tendering, which was very voluminous job, very time consuming job, because what we are talking is lump sum fixed price contracts. When we say lump sum fixed price contract, this means there is no question to be raised later on. Whatever we have to do, whatever we have to work out, whatever we have to consider, that's only before we submit our offers. If that is the case, when we say, okay, we will do this contract work, this reference work for this sum of money, and we shall do it in this period of time. And that is, you can say, essence of contract. Time is a factor, cost is a factor. This is cost, I get this, you pay me, and in your proposed time I complete this. And that's what I think is contract. Basically, I have agreed I will do it, then I must have capacity to do that. Of course, I will prove my capacity, and then I do work. Before bidding is closed, every calculation is done based on designs. Designs dominate our bids, because designs tells us we have to take out information from design documents about how much work we have to do, how much work in every field, in every activity we have to do, and every activity has some units. We know that square meter, cubic meter, running meters, or weight, or whatever else. All those units we have to use in our calculations, and we work out a list, and that's called bill of quantity. Generally called bill of quantity because rates are not available in that. Though there is a column of rates and there is a column of amount, there is a column of remark also possibly, can be, and that bill actually gives quantities this is quantity. You have to work on this contract or on this work. You may call it work now. And whatever is quantity is a responsibility of design. What is design? And when design is there, everyone can work out quantity on that work. Yes, there can be errors, but generally quantities are worked out for each and every item, and we have to then find out unit rates of every item, how much it shall cost. That is not a big issue because it's called analysis of prices, analysis of rates we call it, in which case we require to know how much material is used in this unit work, that material we have, or we can say what is cost of this material. We can find out cost of each unit, and we can then multiply what quantity we have worked out from taking off. That activity is called take off, means take off quantities from drawings. Even if we have other quantity list, or you can say bill of quantities given by engineer, we have to make sure that these quantities are justified, or we have to use our own quantities. Contract is full of quantities. There may be hundreds items, many hundreds items. Of course, items are repeated, but quantity is changed in every one. How many buildings are there? How many contract parts are there? Every part has certain bill of quantity, and it is better if we keep separate bills for every area from many future purposes. We cannot just combine them. Yes, we combine them at end. Bill number 1, bill number 2, etc., and bill number end. And we can say this is price from this bill. We carry over, reflect on that sum, and then we can sum up all those attachments, all those bill of quantities. I just described this very preliminarily because people should be clear what is about bill of quantities. It's not very important part. It's a bill. Bill means a descriptive quantity. And when we work out our contract, ultimately we have to handle this. We have to handle with this bill of quantity. If our quantities worked out is not correct, our quantity is not correct, we say, okay, I worked out this quantity. There can be errors in that, and those errors are audited and checked. Idea you can know only from answers from quantities. Oh no, there's something wrong in these quantities, and that work out. Because if quantities are not correct, say there is a difference, there is an error, it can be very difficult to handle that. Means quantities approximation would not do. Quantities expertise shall do. Major quantities particularly, which are very expensive, means you can know it from your calculations, from your takeoff. Generally, we can say that if you have some units of areas, covered areas, approximately we can say approximately how much quantity should be there for these items. That is called experience based knowledge. And if we can't do that, then we are not engineers, I can say. It doesn't mean that you can call it thumb rule. There's no thumb rule here. Just approximate area you have, and you can even take normal thickness of slab, and you can say at least this should be that much. Well, it's different view. We take exact quantities. We have quantity engineers in organizations, and they work out that. It's not time consuming nowadays because of software, because of worksheets. This can be done very fast, but very fast doesn't mean accurate. We have to keep an eye on every data entry. Sometimes there can be errors, and those errors can be identified by experienced people, not by everyone. So when we talked of bidding, this quantification was major part in construction contracts, particularly because we have to construct what? We have to construct quantities of materials, quantities of items, and that construction means we spend money on that, we spend resources on that, and we should get back only our fixed price we have mentioned, and that fixed price includes quantities of all requirements. If we cause an error, this means it shall be error for our organization, it shall impact us very adversely. If we make mistakes, and quantities means exact work. If we depend on quantities, okay, rates can be different. I'm not saying about this. It's up to you how much profit you want to take on that item. That's where competition lies in. Every company has experts to work out quantities, they can work. There is no challenge to that. Maybe 1% variation could be there, depending on some considerations, some marginal errors or marginal tolerances that we consider in construction or estimation. We call it estimation of quantities. And once we have estimate of quantities, then we can apply our prices or unit rates on those, and we can say this is cost of this item, this is cost of this item, price of this item, and we can sum up all these, which we get total price of this construction for this area, and for that area this one. That's quantity must be done perfectly, and also if pricing should be logically. Before tender is submitted, all this is done. Even if we get document of BOQ from engineer, we should revisit it, we should relook at this, and we can do only when we have our own BOQ. If we compare that BOQ, documents given BOQ, we can make our own BOQ. Yes, it shall take some time, but it's your work. If your own quantification can save you from problems, that's a requirement then. Why should I suffer because of mistakes? I'm not saying that I don't trust engineers provided BOQ, that is trustworthy. But we are talking of work, we are talking of real work. There can be errors anywhere, everywhere, and those errors are very expensive. These errors can drop your organization, if you don't look at that. So quantification is very important requirement. I see on internet they talk of thumb rule in designs, they talk of this and that. I would only say don't be in a hurry. It is civil construction. It's never done in a hurry. It's done with full confidence and full patience. If you have patience, you have confidence, you can be efficient on project. It doesn't mean that be in panic all the time, because in panic you cannot find answers. You must have cool mind, smart mind, thinking mind, concentration mind. Only then you can concentrate on designs, because the designs are not your one. You are given these designs, and are these designs clear? That's your job to know, your job to investigate or scrutinize all documents. What problem does exist? What deficiencies are there in designs? Or more information is required on those available designs. No one can construct anything if drawings are not clear, duly coordinated, and information required for construction is included on these drawings and specifications. Specification, which is very much technical work, is not you can say side work. It's not side work. It's not something that can be ignored, because when we say designs, specification, writing, or what you have to do, that is called specification. Specification is integral part of designs. If you think I'm only structural designer, you may be structural designer, but your responsibility goes to structural specifications, composition also. If you cannot think what specifications is required to be followed on this item, then your design is incomplete. It should be clearly accompanied with specifications, because specification means change of working, change of quality difference. Specification means you have to find suitable material that can or on which this specification can be operated. That is where specification values. Specification does not mean a paper. This means functionally it is to be done functionally, or physically specifications is to be applied. And when it is to be applied means it should be workable. It should not just copy paste. It should be workable. And in fact, it is high responsibility of design engineer to care about specifications. Design cannot be taken just drawings. It is specification as well. Therefore, engineer's job is not that easy as we think. It's difficult job, it's responsible job, and it is continuous one. It's not 1 minute decision. Every activity requires concentration by engineer, and if engineer can concentrate there, I think in that case results will be different. Results will be encouraging. Enthusiasm would come in, because when you think and do something, life is different. When you do something yourself based on your own thinking, you will find that it's kind of research. You will find your own errors as well, because you concentrate on that. Otherwise, others will tell you this is your error. If you are a good professional, you should know your errors yourself and handle them before something comes to impact on you. That's where I say design is very much related to construction. And construction means a product of design. Construction doesn't mean just construction. It's direct application of design into physical product. What we say, then what evaluation we have to do? Yes. What did we get? Did we do right way? Did we properly study our designs? Did we properly study specifications? Did we find certain clarification requirement? And we go through study all documents. It may be technical aspect, it may be legal aspect, it can be project aspect, or it can be whatever else. We have to know. It doesn't mean you have to sit down all time and read specifications. Generally, specifications are well known to all engineers. But certain specific points do exist, which we have to take care of that. It is in designs, it is in construction, and it is everywhere. Construction, we cannot take it just a physical activity. Construction is not physical activity. It is physical, but not entirely physical. People think it is physical. That's unfortunate. I say physical is one part of it. Physical is one part of it, but other part is also important that we must take care of. We must understand that. That's the important part. And that part is its being. And that part is art of working. That part is contemplation. And that part is design. Designs can be converted to physical work. How it is to be converted? What is best way? What is best possible manner? That is the point where we stand. Methods can be worked out. Activities can be carried out through methods. But what is best way? That is job of an engineer to define. Just like we say performance evaluation here, class 9. Which performance? We have to take into your consideration, just like it says, construction operations are monitorable and measurable for purpose of further analysis and earned values and evaluation. Monitoring, measurement, analysis and evaluation is a defined process which requires to be conducted by both internally deployed management as well as defined schedules by external third party audit. Point is, when we do it, forget audit, forget others. When I am there as engineer, I am asking engineer myself. I am raising question to myself. Whether I am intelligent person or I am not intelligent person, I have to raise question to myself. Means, am I qualified to concentrate to know changes in this design or its implementation? Okay, I am not here to change design, that's fine. It's not my job until there's some problem. Until there exists some problem. Suppose there is no problem from design viewpoint, then my duty starts to chart out which method I have to adopt. There can be many methods. I am a contractor, so I am an engineer of contractor in a contracting company. My job is to do this work in best possible safe manner, in best possible manner where quality can be inducted to maximum extent. Am I powerful for that? Am I powerful for that? Or do I have that competency with me that I can cover up what I say? And that cover up is my capability. I can discuss with myself, I can discuss with my workers, my foreman, I can discuss with someone else, some craftspeople, what is best possible way. If I talk to 4 or 5, I will get 4 or 5 answers. And I have my proposal also. What we have to consider in construction is cost. We have to consider time. We have to consider quality. These are primary factors. We can say cost, quality and time. If I can give best quality with minimum time, or I can give best quality with normal cost, or I can give better quality in normal cost by whatever method, even if time is saved by use of certain method, I should prefer that one. Okay, quality can't be down, it can't be upgraded, at least whatever is expected, whatever is specified, that should be achieved, and I can save time. Say, by this method I can save time. For example, there's a saying, if an engineer or some foreman can think of one process, one method, or two methods. An experienced contractor can tell you five methods. This means there is no dearth of methods. There is no shortage of methods. Methods can be thought of, can be devised. And there is no hard and fast rule to an extent. Whatever method we opt for, we do that safe, and we do that keeping in our view quality operations, quality applications. Every method is fine. Means it's not simply achievement we are here evaluating, we evaluate our own methods also. Because every project activities are different, and we can change on every project our methods, or we can keep them same. That depends on, you can say, reliability of that method. Reliability applies everywhere. This method we do, our people, our workers learn that method. There can be any whatever item, they learn that, and they learn many times, and then a stage comes that they do themselves. They know how did we do there. I can do it, no problem, I know it how to. Maybe that person is not able to explain, that is different, but those people, those workers, we can say them, they got training, indirect training of these methods, applications of those proprietary products. There can be many such activities that our people have to learn. We have to learn only, not our people. As an engineer, I may also learn many activities which I don't know. It's because of advanced materials, continuous developments of technologies, and continuous applications of methods, applications of technologies. Whatever we do, we have certain fixed items. We have structural items, we have non-structural items, we have soil-related items, we have foundations, we have superstructures, or we call ground structures, above ground structures. We have different disciplines, and we have many other activities which are done only once base is ready, and that base is structural, you can say, formation mechanism. What structure it is, can we rely upon that, or we cannot rely upon that? Can it move like this? Can it move like this further? And how far it is efficient, how far it is consistent? We have to depend on that. This template we are talking is a structural template of whatever we do. This is not an ordinary template. This forces everyone to move in an innovative direction. All time you have to think, can I do better? Means sometimes there are typical items, sometimes there are non-typical items, sometimes form work can be used, for example, 4 times, 5 times, sometimes 6 times. Is it better to continue that form work or to procure new? Means it shall affect workmanship, it shall affect quality. That's why there is set procedures. You cannot use this material after working with it so many number of times. And then that material which you use for that activity, that you can say proprietary material, at one stage becomes so out of date that it cannot be used. Then we have to buy new one. But we have to make sure that how many number of times I use that, it should give me return of that cost. This means if I use plywood for 6 times, 5 times or 4 times, it varies in cost. It varies in cost. And this means excessive cost means then loss of budget. And If we have more repetitions, then you have to face damage to your quality system. There are so many such methods. For example, plywood cannot be used more than 6 times, or even on ordinary work. But scantlings and battens can be used many more times because these are not spoiled by concrete work. Battens, I mean to say timber battens or scantlings, you can say. It is say 50 mm by 75 mm pieces, or 50 mm by 100 mm pieces, or 50 by 50 mm pieces, sections which I'm talking. Those can be used and it shall reduce cost. But question is of quality. Quality shall be at stake. We have to keep that point in mind. That finish which we expect from timber or plywood, that cannot be achieved by steel surface, because remaking of steel surface is not to that mark as we can do with plywood. Remaking means once I make one original work, I attain something, I prepare say side of a column, shutters, we use timber scantlings and plywood, and we can level up that to whatever dimension. That is first production and first use of that material of ply, and we cast column. We take out shuttering at required time. So we say this first work has been done, first use has been done. Now I have to use second time. This means first time it was made, it was called making. Now making is already there, but we have to, because it has been used once, there can be undulations on surface of plywood, there can be nails, or there can be some other defect in that. To use it another time, we have to bring back to that position of first use when we finished making of that plate. So we have to bring back to same state. Of course, we have to use second time. This process to bring it to same stage and use second time is called remaking. Remaking of that. It means second time use remaking, and then third time use remaking, and then fourth time use remaking, and fifth time likewise. Every time we have to do. This means every time we cause some damage to its property. Plywood would weaken, it will not have same strength as it was in first go. Same way its other parts, these scantlings or timber pieces, would also be to some extent difficult to handle smoothly. But we cannot do more than that when plywood is used. But quality of remaking can be better. It can be much better because it won't take much efforts from our carpenters to remake that. Then we can say, okay. When we talk of steel plates, of course, steel plates are heavy. They require backup, different backup, and we can do it, of course. There's no problem. But when you do second time, because these are steel frames, steel plates, remaking would cause some problem. It is not easy to remove undulations from these or to bring back to same status at one first go. This is a difference of approach of working. And of course, there can be different problems, particularly when we have good finish required, then we go for plywood. Very commonly because of ease of working and ease of handling. The only difference is steel plates are expensive. Their use of steel plates is expensive and maybe it's used 50 to 75 times. Generally, I think they may say 100 times. It's easy to say 100 times, but remaking would always cost more and more. So that's why I'm saying it depends on evaluation of working performance. How does this item perform? Material is a part of that. Inclusion of whatever material for that work is important. Here in temporary works in our country, particularly we find on private buildings, timber bullies they call timber or wooden bullies, they use for scaffolding, they use for supports to slabs. Of course, this is not quality item. They use not only these timber bullies or you can bamboos, they use also planks, timber planks for formwork. These are hired one and these don't give that surface finish, that concrete finish as plywood can give or steel plate mechanism can give. But nobody bothers here, though it's a part of engineering. They don't bother of honeycombing, they don't bother of whites, they don't bother of anything because they do not know what's the defect. It's not their fault. It's not their fault. Our carpenters, our masons who are not very well trained on projects, they don't understand meanings of these technical terms like honeycombing, like voids in concrete, like surface joint defects. All these are foreign to them. They only know, okay, there is some defects, we will cover it with mortar. They have that kind of conception. I can't blame them also because they have not been taught about that. Evaluation is not quantity alone. This is also a part of evaluation, technical evaluation. How best I can do, what is best way. Means resources remain same, only application of quality is different. If I can remake in a fast manner, I can remake in minimum time that form work and I can bring it to best possible standard of quality system. This means that remaking is best for me. But it should be properly monitored and our skill training should be imparted to everybody on site. You need not go to some institution for that. Site qualified engineers who are experienced, they can very well explain to them what they have to do through directly or through foreman. The foreman should be a teacher for them and foreman should be a student for engineers because engineer can teach that foreman, but it usually happens that foremen are technically strongly backed and they know their job, but knowing a job and further improvement, continuous professional development is very important. So if you say it's a like, we say in medical world, this management, that management, you can say it's workmanship or work management. Work management does not mean only records. Work organization doesn't mean only record maintenance. It means process of quality maintenance. Workmanship or work standard is a part of quality. It may not be material quality but working quality. How best I can do this? When I do this, my site should not open or bulge. It should remain in its position until concrete is hardened. There should be no sagging, there should be no hogging. Level should be same. It may be horizontal control, it may be vertical control. In both ways, Lines are same, should be same. Lines and labels we can call in every activity should be same. And to do that, and to how to do that, and is it really possible to do that? And we should do it on site, we should try it. We can say that we can improve our mechanism of working. As I said before, methods can be varied in quality. Sometimes people don't bother about millimeters and sometimes people bother about. It depends on the circumstances one works. Because every project has different approach. Some people excuse only, oh no problem, this will not be seen and this shall not be seen is really very attacking talk. What do you mean shall not be seen? Seen or unseen, defect is defect. Inefficiency is inefficiency. Maybe people do not know it, but it is there. You know it. And if you know it, time will know it. Maybe you are not there that time, but your work shall suffer. It will jeopardize other items. It's therefore very important part of monitoring. It says construction operations are monitorable and measurable for purpose of further analysis and evaluation. Monitoring, measurement, analysis and evaluation is defined process which requires to be conducted both by internally deployed organization as well as at defined schedules by external third-party audit authorities. Many observations are recorded by both internal and external auditors, which noting and instructions should be entirely reviewed by top leaders. Top leader then requires to decide degree of compliance of current system and make it fully compliant, and also what degree of value engineering can be inducted onto existing system for further successful competitions. I think explanation is very smart. It's very short as well. But its impact on construction items is very widely spread. Very widely. Ignorance does not allow us to go to that. Ignorance is very harmful. Just like we say in ordinary way, compromise. Many people tell me also, no problem, we compromise. I don't know this English word. Really? Meaning we know, but this word we do not know. What does compromise mean here? How does it work? Can engineering be based on compromise? One question comes to my mind. Can engineering be based on compromise? My answer you know very well. Yes, if you want to talk to 10 engineers, you will find 10 answers. Varying answers. Maybe 7 or 8 says, oh, no problem, we accept this compromise. May say, what goes wrong with that? Somebody compromises, somebody doesn't compromises. Those who say, okay, I can compromise because I'm a practical person, then I don't understand meaning of practical person. What does compromise mean? What does it mean? Well, I think nothing. It means nothing. You are accepting wrong as right. That's compromise. Or you are getting super. What's compromise here? If it is super, then this term cannot be used. Compromise. Because you have given more than promise. Now, promise. Is it right word? Promise. Is contract based on promise? Can promise occupy a position in a contract? My question relates to this terminology. Is this a contract or a promise? Promise is always blank. Promise has no solid power. Promise is promise, but it has no binding. Promise has no binding. Binding means both are bound, not one. But contract is a binding. It cannot be declared void of binding. If there is declaration of void on binding, then it cannot be called a contract. Contract is a liability. Contract implication is a requirement. It's for both, not for contractor, not for owner. In isolation, it's for both. Both are bound by terms and conditions of contract. And there where difference lies in. We can say it's a mandate by both parties to each other. It's a kind of charter both authorize reciprocally each other. It's the legal right. Legal right, it's many legal rights that exist in between both parties to contract. So where is promise then? This means promise has flown away. It has disappeared, but binding exists. Until contract is valid, even after work is discharged, contract power remains valid for whatever purpose, for disputes resolution or for some other purpose, because it was a binding. Binding for warranty, binding for guarantee, binding for performance, binding for service. Wherever impact goes, these requirements are automatically imported from effect of contract. That is the reason I always stress on contracts, because everybody sits on contract. Engineer is a part of contract indirectly. Owner is primary part of contract, and contractor itself is integrated part of. So bindings of provisions of contract are linked to both means owner and contractor, and its administration remains in hands of engineer as far as work is done and contract is not discharged. Till that time, engineer is also bound by professional responsibility. There are many responsibilities, but here is professional responsibility of engineer to make sure that whatever is given in contract, whatever is available information in contract, that information must that information must be applied with. It must be cared for. I'm sorry. That information must be cared for, and there is no way out to avoid or to run away from that aspect of information. No one can run away from this. Reason being, because that is binding on both. So we have to understand the power of contract. Nobody is slave to each other. Nobody is upper or lower to each other. Both are parties. One has one responsibility, another has another responsibility. They have agreed on something. They have agreed on to do, both have agreed on to do something. Contractor has agreed that work shall be performed accordingly, and owner has agreed that when you perform this, I shall pay you, provided and under limitations of these contract conditions. What's harm in that? Then question arises. No harm. It's a way to do work. It's a way to do work because I want to get advantage of contractor's experience. I want to get an advantage of contractor's experience. That's right, point means. Contractor means an experienced person. Contractor doesn't mean lay person. And I don't have that experience, but I have experience of using these items which contractor shall deliver. So my expertise is different. I am a promoter, I am an employer. I promote my business based on how contractor delivers. Both my operation is long term because this work, this project shall be used for many years to come. This means financially it shall be applied in long term. And contractor's responsibility is to deliver to me what is required. If contractor fails to deliver that quantity wise and quality wise, then I shall act against contractor, and if contractor does it right, contractor shall get full payment. This is relation, professional relation between two. And when we say contractor, it's not one person alone. It is a group. It's a group of experts. It's a group of professionals. And same applies to employer also. There are different kinds of professionals who organize employers' world. So here we can say in contracting world, improvement based on evaluation. Improvement comes into play. Where did contractor make a mistake despite having experience of so many years? Mistakes happen and there are reasons for that. New items come in, new designs come in, and of course people keep on coming and changing. Engineers come and go, technicians come and go, experts people come and go, and we keep on changing our status. Therefore, we can say technological variation exists, methods exist, they vary, and drawings vary, specifications vary, and we have to understand on every project something. We have to learn new, or we can get more information, or you can say nature of project also depends, it also tells something, where we have to stand, how deep we have to go into that. In-depth study, it's once only, you can say, very easy if you do it once, and then you can think on. Nothing can be studied in one go, but idea, grasp of requirement is really very significant, very significant. If grasp of requirement is good, it's like, when you study for examination, you have certain syllabus, and you study major part of that syllabus. Nobody can study 100%, but if you study 100%, it's also excellent. You have done study for whole. We can study contract in similar way. Somebody got interest, somebody didn't get interest. Those people who are new, they of course take interest to learn more and more. and they do also. But those who are experienced one, they do not need learning to that level because they already know. Sometimes when paragraphs and pages are seen and further pages are taken up because in that page person finds nothing specific, but a person who is new, and a manager who is new, that person will certainly try paragraphs or lines to learn more and more. But here is analysis I am talking of. We have to compute procurement quantities. We have to compute everything. What is quantity of timber I need? What's quantity of battens I need? What's quantity of this material I need? What's quantity of nails I need? Binding wire I need? Calculation details of steel reinforcement. Likewise, it's not list of material items. You cannot say it's BOQ then. It's further details of BOQ. Means we have to work out based on quantities available, quantities of items. We have to procure further requirements. Requirements is what? We have to procure basic components like for every item, reinforcement, formwork, finishing items, brickwork, blockwork, or whatever else. You have to make out a list for reference, and that list can be called list of materials. It can be comprehensive list for every part of contract, as well as it can be element wise, or you can say building wise or area wise list of every such material, which is kind of asset for that project until that project is over. Means you have got hands on controls of quantity requirements. How many cubic meter of concrete I have to use in this building, and on this ground I have to use this much, as well as on in foundations I have to use this much. That reflection is very important to work out resources required, to work out time required, and it's a pre-evaluation stage, you can say, though it's evaluation of results, means how much do we need, but it's very important thorough research, you can say thorough application of your real ideas. There's no imagination in that. If it is used, it is used. It's required, it's required. Such work, though it cannot be classified, because it's a fact, by studying all this, you can say complete details for working, and you cannot just move in a panic way because you have details with you. And this applies not only to civil items, this requirement applies to all items of contract. The same way we can design also. But I am not talking of designs, I am talking of work, construction work. Information, I say, is very important. Information, this information, we have technical one, this details you have to give to your boss or to yourself for record purpose, for planning purpose. But for foremen, for site leaders, site people, site personnel, you have to give different details, and that can be linked to information that you have. And that can pass from time to time. It's not necessary that you have to give one day. You have to order concrete, you have to order for material procurement. That detail shall help you. It shall take some time, but once you have that detail, it shall help you throughout project. And that's called a kind of personal level planning. and it can be used for level 2, level 3 plans, or those people planning guys, if they are good, they can give you these details, but it depends on them whether do you know how to work. So I cannot assure here. Yeah, I would say all those who work on sites, better you do it for yourself. Once you do it for yourself, this means you have gone through complete drawings. And going through complete drawings means a lot. First of all, clashes will appear. You will know facts where there are errors in drawings, and this will indirectly give you input for raising technical queries. When you go to find quantities, certainly you will refer to specifications. What is specifications speak about? This means one requirement shall give information about other requirement. And this is what we say this work is about. This is what we say self-movement is. Means you had to start, you had only to initiate, then your vehicle keeps on moving in some direction. And direction was you had to find these quantities. And during that, you refer to documents. So you find technical clashes, or you find some other requirements, and that's where you have to deal with that. You have to deal with people, you have to deal with resources. It's really significant, you can say. Here, though we are talking improvements, and this is also improvement. You have to improve your work, and improvement of work is improvement. If your work can help you, it shall help everybody working for you. It shall help all technicians, it shall help foremen, it shall help supervisor, and it shall help you ultimately. So there is no confusion in that case. What we are going to build, everybody should know. Particularly those who are going to be involved on site work. They are supposed to know that. And if they know, they shall have a level of confidence. They shall have a high degree of confidence. Oh no, we know what we have to do. Don't tell us. Of course they may say like that, but if they know, it's your achievement. That before doing that, they know. And then they can think also that my senior thinks for work, then I have also to think for work. And many of them could come to you to give more information about this, to find more information for them. That could happen. So I say this monitoring, or you can say this process of piercing into details, is very much reliable for doing improvement or causing improvement to something which is unclear. And once you do that, then you shall come into contact with quality system also. What quality requires, and you can say checklist is complete or not complete, ITPs are not clear or clear. You have to deal with all these informative issues. It may look I'm talking unnecessarily, but I'm talking what I felt, what I experienced. My own intern means it's not everyday's job, in fact. It's not everyday's job. It's a job afflict few days, maybe in a week or in a month. Because once you have done job, after that you won't do it again until there's some change. And because you are doing on electronic spreadsheet, change won't cause any harm to you, it won't give any headache to you, because it happens very fast. Only starting time you have to give when you prepare data sheet, Maybe you have to take measurements, length, width, height for purpose of quantification. And of course, you know how much is shuttering. Means that's of course you have already got test material based on some quantity, and that material is with you. You can use that material. But how to use it best, that's only issue. You have made your life easy now because you have details. These details are not only for you, not only for your personal use. These details are there for project use. People shall come to you and ask for these details, and that should happen. If nobody comes to you, then you can use these details. What's wrong? Use it. It's for you. You shall have confidence because you have worked out everything. To an extent, construction is concerned. You can then raise questions to planning people, to others. It seems that there's something wrong in this chart. We don't have this scope of work here, or we have limited scope here. Why are you wasting time? Oh, okay, you are giving some time, fine. What about material? You can place order in time. You see, what I'm trying to say, control of works. Control of works from practical viewpoint. Keep aside everything else and think of what do you think is best time for this. Keeping all other factors in your mind, contact factors, schedule factor. Can you move it different way? If you think it can be moved in different way, using your ideas, there is no bar on your ideas. As far as project interest is related, you can, if you have manpower, workforce, that you want to use it better way, and site can be controlled in a better way. It's not necessary that what is written you have to do. You can apply your mind to achieve quality, to do better work. You can open up more areas to work in same time, though it may not be scheduled out, but maybe you find some ease on that, or you want to show that we can do better. You have to use these machines which were lying, standing for nothing. So you can start up more areas. And start off in controlling more areas means you are moving faster than required. And that approach is acceptable. Here I say communication and coordination to yourself. Methods of working to yourself. Means you are doing as a student. You've been working as a student of engineering, and it is reliable working because you are responsible. You are not only responsible, it's a job. You have to do everything on that. You can say it's a kind of calculation world. Calculation and implementation of calculations. Best and optimum use of equipment. And you have to get more information about every person that's associated with you physically and with your internal arrangement of projects. How can I move it better in a best possible manner? I'm not saying you'll do some extraordinary job. It's interest. Some people are experienced but they don't have any interest because their interest is different. Some people want to learn engineering. And remember, engineering is not short-term learning. It's not short-term learning. It's not talk. It's not lip service. It is real service. It is physical service. It is design service. It is a service that cannot be instructed, but one has to have interest at every point in this engineering, and particularly civil, that is construction, real estate, it may be road work, it may be resources, it may be whatever else. You have to involve in physical work. In physical work, we have to involve in, and where quality is also a question mark, it has to be achieved. Where safety is also alert, and alert it is, and we have to do it successfully for getting our payment. And if we do non-conformance, of course we invite problems then. And it's very easy to say non-conformance. Okay, there is non-conformance, so we have a method or new method to solve it, and we solve it. So what I'm saying is, work of project engineering, work of really working on projects is very innovative idea if we realize that. I know civil engineers are very smart people. Civil engineers are very dynamic if they are real civil engineers. And if they are no, I'm AC civil engineer, I don't come out of home, I can't devote my time as such. This different case. Civil engineer's nature should be, I have to do something different. And that something different is really wonderful. I'm going to do something different. I cannot keep on this. I cannot move like this alone. I have to work frankly. I have to think. I have to use my mind. I can do better than other thing because you are on site. You know everything, what is going to happen in site, what is requirement. You can immerse yourself in that. Not all time, many times. And you can find, I can do better than what is expected of. Because your job is to deliver from site. It's not design. You know how best you can do it. And that's the job of engineer. Engineer cannot simply say this was a problem and this was a problem and this was a problem. I could not do that. If that statement engineer gives, I cannot accept that statement from engineer. Yes, if foreman, if supervisor, if someone else talks as such, that's acceptable, because I can't expect them to be that level competent as engineer should be. Really, engineer means a person who can think. And if I don't think, or if I cannot think, and I am holding a project as engineer, as leader, well, I think that there is some error in my appointment. Or maybe I am very good, I don't know. But my job is to think and solve problems as engineer. Thinking and solving problem is engineering. Thinking how could happen, how it did not way, how did it come out different way. We have to think as such. Really, we are not people not to think. We are people to think. And that thinking is engineering. It's thinking activity based, it's design based, it's whatever sort thinking. I stress on thinking. Your thoughtful mind shall help project. Your thoughtful mind shall help everybody. But if I close down, or no, I can't work high, I can't work this way. And it's different situation. But improvement requires you improvement on actions, evaluations on actions, making and further making, review of whatever you are doing. Your review itself will tell you something. Oh no, you have not done it right. Which will tell you something like that. Review, re-evaluation, improvement, and thorough understanding are all linked together. Understanding is a concept. Maybe it is defined, it's a concept, but it can be redefined. It can be re-evaluated. It can be given a new mode, new shape. So it's not that difficult as well. For an engineer, this activity is not difficult, but for others it may be difficult. It's the way when you design, keep on designing something, your mind keeps working. Minds keep immersion in those details. Maybe you're working on papers, but something is written in your mind. Something your mind is developed. And that development is reasonable, that development is required. When we say evaluation, when we say improvement, construction improvement is root of success. Frankly speaking, it's not planning alone. As we say, construction is a very widened world. It's very widened field, and it relates to others also. Sometimes we don't have real information when we do work. Then we assume, okay, it should be like that. Without even knowing reality, we sometimes imagine ourselves. But if you have real knowledge, if you have some documents clear, not only documents clear but mind clear too, explanations clear to maximum extent. Project construction is very difficult if it is not well understood. That's why we call it concept of project implementation. What project we are going to do, leaders should have clear answer of that. Leader means top director. Means yes, you will be even support from others, but your efficiency is required to do better job. Every time we should do better job. We should do tidy site. We should do safe job. We should think of quality every time, and we should think of improved life. If we cannot think of that, then you can say there is no factor, engineering should be interpreted accordingly. But interpretation of engineering means interpretation of everything, because this gives us specific answers. So when I say improve, I want to improve on every activity. It's not structure alone. It's not structure alone, it's every part of work. We have to be ready with. Improvement on every item. For example, improvement on excavation. It starts with improvement on investigation of soil. It starts with improvement on whatever foundations we do. It starts with, including pile foundation, micro piling, or whatever other foundations. It starts with very beginning. with even surveys and how shall we install our work. Every point should be crystal clear. It's not for 1 hour. Again I say, establishment of construction is not for 1 hour. It's never for 1 hour. So why say improvement? It is AnnexSL I'm talking. It's the widened one. It's not that at end we understand where were we wrong. Why not to take it in beginning rather than considering it as the end? Whatever we go to do, is that right? This point should be answered. We have to answer ourselves, or someone else has to answer us. Only best way is we have to answer ourselves. If we can make changes to ourselves, or we modify our activities, that answer should come to us just by thinking or by having some discussion with someone. Technology keep on changing. Likewise, methods keep on changing. Likewise, thoughts keep on changing. I'm not trying to say that you shall be contracting worker. It's upon opportunity, which opportunity you get. But I consider contractor as responsible, professional, more responsible because contract has to do and deliver. It's not part work, it's full work. You cannot say I have done this much, I am not able to do this, I am leaving and you do it yourself. It doesn't work that way. Because it's a binding, again I say, contract is a binding. Contract is a binding and it should be taken care of that way only. And if you don't take care that way, we certainly make mistakes. And making mistakes is no way around. We have to take that point also into our consideration. We make mistakes for nothing, that won't work. We have to understand that point. Even if there is a mistake, we should know how to correct it. If that capacity we have, no problem. Mistakes can happen. Maybe you don't do it, somebody else does it. Maybe there's a problem of communication and maybe somebody doesn't listen to you, and that can lead to mistakes. This can happen. But it should be traceable. It should be remedial. If actions are taken, we don't have remedy. I mean to say, if our quality person is strong and that person takes action as his own organization, that's where credibility lies in. You can go oppose your people, and that too without any paper, just sitting at home. There was application lies in practical life. So we have to be very, very considerate on this point, and you have to give me a few minutes. Now I'll be back, and meanwhile, if you wish, you can read another document that we will take soon, and that is AnnexSL company. Where's that? Building construction. It's that one. Also, the building construction is this. AnnexSL. EPC, yes, is that one. Meanwhile, if you wish, you can read that one. I'm presenting to you, and it is about EPC. Give me, I'll read this. I'll be back in a couple of minutes. Gentlemen, I think you've gone through this. Really have gone through this. They're expecting you to go through that. And you must have gone through that to some extent. The CPC was talking about, I'll just read little one for brief discussion. This is EPC contracting facility, and of course we're talking a building construction. This AnnexSL, that is EPC contracting, and what it says an organization that adopts a management organization system to take care of comfortably achieving its set objectives, which being in this case winning from certain plant promoting company and EPC contracting for facilities and related building construction. This system comprises various sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which lead to enhanced use of resources, improvement on risk management, and increased company satisfaction by meeting product or services expectations. In this case, product is EPC contracting facilities, buildings construction for certain plant facility, which facility being promoted for implementation or implementing patented technology through defined chemical process on plants producing required products. Organizations do work on various such systems, say quality, environment, safety, security, etc. All such systems apply in this case directly as well as indirectly. These systems, in line to ISO 9001-2008, used to work on varying structures, causing inconveniences to interface with each other. But now all these issues have been dealt with as framed in a common template, that is AnnexSL, being a high-level system structure, has produced a common platform so that all systems that organization adopts can be drawn based on AnnexSL designs format. EPC contracting facilities, buildings, construction can be easily defined within AnnexSL format. In this case, intentionally both promoting company and EPC contractor have been tried to be included on one AnnexSL format only. For purpose of clarity to understand real working on such projects, though practically both promoting company and EPC contractors adopt their respective systems separately. Such arrangement provides many commonalities in designing system, implementation, monitoring, evaluation and improvement by trying to eliminate conflicts that existed within 2008 system. Various stages related EPC contracting facilities, buildings construction can be covered within this AnnexSL template successfully. All systems shall have single high-level identical core text with common terms and definitions which can be defined within AnnexSL. High-level structure cannot be changed, but discipline-specific subclasses can be both added or changed. As such, additions may be made where required related to EPC contracting facilities. Plus buildings construction, AnnexSL applies to all management system standards publicly available specifications and technical specifications as well as customized requirements. Okay. Revised ISO 9001, 14001 and 45001, etc. shall all be based on AnnexSL high level structure, where related to in this case, though not included herein. AnnexSL template shown below is only for indicative guidance to apprise an engineer how new system adopted by organization ISO effective step 2015 work in product produce organizational prime quality document which govern whole organization quality process required by business, adding accountability shareable by business or and technical leaders. Wherever wherever and whatever requirements demand, items can be added as subclasses, but no deletions can be made. Purpose of this template is just to project quality checks, quality track demanded by ISO system, which is mandate published by ISO and without which applications all existing registered certifications shall stand invalid after 3 years as September 25. Okay. Therefore, AnnexSL options must for new quality system operations. This is background. I will not go further than that because I'm busy on previous one, and that is this one. Now we are talking of improvements, and that is, you can say, final end of this form, clause 10 improvement, and which includes dealing with non-conformity and corrective action, continual improvement, in which case considerations are changing business environment, processes and objectives vary to meet which requirements, continual monitoring, evaluation and improvements are a must. I read again. Stated earlier that technologies keep on changing as well as business environment, which makes it incumbent upon the organization to keep pace with market so as to be at required standard mark. This requires review of non-conformities, resorting to corrective actions for charting out corrective action. Such making or evolving keeps system frequently updated, and all involved personnel continue to learn and update. All leaders require share improvement responsibilities. All this time, at currently running up projects and adopt as lessons learned on future projects as part of historical reference. Though it's very simple looks, but it's not that simple. In fact, it's encouraging, and it's, you can say, when you say conformance or non-conformance, a point lies in, it says very clearly non-conformance, which is something unacceptable from quality viewpoint. Non-conformance, something we cannot digest, as we said, non-conformance means engineer is either careless or ignorant or incompetent one, and therefore is a redundant personnel. We must change to meet requirements to achieve intended quality standards for universal recognition of products or goods. Quality requirements checks being a must, missing which We have to blame ourselves for quality achievement failure. Engineering means quality application and continuous improvement of quality. No way exists not to comply with defined or specified quality levels because definition of quality is a must and that definition requires to be achieved or else work leads to status of being unsuccessful and to be reperformed. Engineers are problem solvers. Engineers are developers, and engineers are agents of change. Engineer can convert a forest or a desert to a city or an industrial town for which quality and SHE play integrated and merged vital roles in all respects. It all relates to designs and prosecution works. Applications must be effective, and that is on both ends called plus 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 engineering, and quality non-conformance products called substandard and therefore rejected. Thinking, contemplation, etc., and power of work, certain powers to achieve everything. Only way we have to raise our power. So, what we discussed here is something very, can say, in this non-conformity and corrective action. Non-conformity. Before discussing non-conformity, we have to understand conformity. What is conformity? What is conformity? That is the question here. When we say some form we have to fill up. Whatever form is given to one, we fill up that form. We don't want to leave any proposed column or proposed number blank. You can see we have filled up this form. Now here is no application form. Here is format of work. When you have to do some work, then work has some design. That work has some format, some kind of procedure. You have to fill in. A format is designed for that. May not be paper format, but some other format. You can say activities based format. There are some sequences for related activities, which one has to come first and which has to go second, or which has to come first and which has to go in parallel, and how has we to do, how has one activity to move, can many activities move together, or we have to study one by one for purpose of learning. But here we are not talking to learn, we are talking to do in a way it is appropriate, do in it a way it is technically acceptable, it is technically sound, do in a way it can be integrated altogether with whatever we do, it corresponds to others to be done and already done. Means there is a complete link. We have to see pre and post both for purpose of ongoing movement. Form is our design. Form is a kind of specification. And specifications is not one, it may be two, it may be 3, it may be 4. It depends on in one work how many specifications pour in, and all have to be done properly. There can be no lapse permissible, which also means that we should know while doing work what specifications demand, what is our role there, is relevant specification applicable to this, and how we have to operate it. It looks very long statement. It looks very long statement as if we have a lot of time there to study this. But practically speaking, it's not a long statement, it's a very short statement. First time it may look like that. But once you know about that, it will just take a few seconds to understand what I have to do. Maybe you know that activity very well. No need referring to specifications because you know those specifications. It's not question of English phrasing. It's question of essence. Essence of specifications. You know, essence is always very brief. Means I'm not going to be interested in translation, grammar of that. But what actually that activities requires. What it requires to do. That's what we have to think of and we have to remember. You cannot go word by word, no need. If you know what is required. And when is something, maybe 3-4 applications, 3 more, means you can say, for example, you are going to do some excavation. You are setting out specifications, you have level specifications, you have how to excavate that specification, how to take care of services that specification, how to reach level, required level, how to support internal sites, excavate and trench sites, and likewise you can say how to take off metal from there. Such all items do play. But already you have done it, or you have seen others doing it. Means it is not that cumbersome as you think it is. It's only relational understanding of what is required. Well, I think that's more important rather than something else. In every item there may be 3, 4, 5 pour-ins or relations to others, and when you understand essence of that, first time, second time, third time, fourth time, after repeating that, you shall even generate yourself what the specific could be, what this relation could be. And then you cannot say you are just a kid there. Now you are an engineer, a mature person. You know how to handle that. So maybe when you are free you can read that, but not necessarily you should read all time. Because generally it is general knowledge of an engineer to know about specifications sometimes. Though it's given in books, in contract books, but if you have gone through one contract, you won't like to go through second time in this same book, because you know context of that. And that context is very significant from every viewpoint. That context is very important from every viewpoint. That context is what you know. If you have 5 years experience on construction, you shall learn a lot in that 5 years. Because maybe you have gone through 2 or 3 projects or 1 or 2 projects in that 5 years. At least projects of structural importance, if not of finishings. But for you to be like that, you know specifications. You don't need all time refer to those documents, because you have experience of those. But just having experience is not adequate. You have to improve your experience by learning more and more. So we can say that you have more exposure to those, more exposure, more understanding towards that, and you can say, okay, I understand that. I, I'm able to project this item. Uh, I know what to do in that. You know what to do in that, but other person doesn't know to whom you are dealing with whom maybe that person also knows, but that person wants you to do in writing what you are going to do, because that's the procedure. What you are going to do, I'm just giving an example. I'm not saying you won't do it. You see, when we say in title communication, coordination, this required effect. This requires effect everywhere. Means communicate. Communicate what? Communicate good morning or good evening or hello, how are you or what? You have to communicate about work. That is what you are paid for. That is what you are dealing with. Whoever to have to report to professionally or in working relations, that person who has to give you clearance about work, that person or officer or whoever it is, that person has to give consent to what you want to do. But where is paper that consent has to be given upon? And that paper you have to prepare, or you can say that statement you have to prepare. How you are going to do this work, and you have to write that. Not only you have to write that, you have also to refer to what provisions of specifications you are relying upon, what drawings you are going to deal with, what standards you are going to use for that, and what safety measures you are going to take for that, what quality issues you deal with, what machines you deal with, what plan of that is on site. All these items constitute a kind of format, and that format, just like this is AnnexSL, that can be called procedure format or method format. Descriptions of what you say is not enough. It has to be in writing. On professional projects, it cannot be completely delivered just by talks, because it is not a communication to be established between two persons, but message should reach to that persons or persons who work in line at site. Those people should know what you are going to do. Yes, you can explain to them, but reference is more important than explanations. They may have documents, they may have everything and through engineer, but the reference is more important in writing, and that too approved reference, which can be called approved document, and that we call it approved method statement for every significant activity. What we are going to do? What we are going to do practically. And that person who agrees with you, who is your controller, maybe, or consultant, to whom you are putting for your work, and he is reporting to someone else. That's way chain moves on. There's no question of inferiority or superiority. It's a question of contract. It's question of operation of contract. You have to operate contract by doing so. By writing a method, conferring with that person, and approving that person, approving your method, of course with some comments possibly, and then that method after final approval has to be operated with in principle, in letters and spirits. But it doesn't mean that becomes religious. That is in principle to be operated, in principle to work upon, but it's all subject to further changes if so required. Maybe in next activity, or maybe in some activity due to some reason. This is your own statement on contract, and approval is also your own, and you can also have second proposal for similar work if you think that may work better. Keeping abreast all conditions remain safe, we can vary it. It doesn't make problem for everybody because it's site work. As far as work complies with requirements, work conforms to requirements, there is no, you can say, bad act done or mistake done. If it complies with all such specifications and documents, there should be no problem in revision of same statement, as well as, you can say, submission of another statement. It's not a big deal, but it is helpful for progress. It's helpful for working, that on record it is, as well as on site it is. It's being implemented according to its status, and of course industrial good practice comes in way also, that has to be complied with. What is said is essence of work, essence of activity, essence of whatever exists should be kept in mind. It should work successfully. It should work to expectations. Conformance means respect to documents, professional respect, not personal respect. Respect to documents by contractor, and respect to documents by employer, and respect to documents by engineer. All these three respect documents, and they respect new documents that are issued by contractor in form of method statements or in form of some other reference. We cannot go behind. We have to move forward. What I stress about method statement, reason being that whatever contractor has to do, or whatever engineers accepts that contractor has to do, that should be known to everyone before work is done. If it's not known and work is done, and then we say this is our method, well, I should say you have your method and you have already worked. What's the meaning of this method? Means it is superfluous then, because you cannot apply it. Already you have worked. That stage should not reach in. It's not that way you have done this work and the design is coming now. What's the meaning of that design if you already worked? Either you have to remove work and do it again. Same way, if method is using this method and remove work and do it again. Is it possible? It's very difficult. Nobody will allow this. This means when we say design is requirement, it's a requirement before doing job. Same way, method is a requirement, it's a requirement before doing job. Same way you can say non-conformities occur. Non-conformities do happen due to whatever reason, negligence of duty, or you can say short-sightedness, or errors on site, or whatever reasons. Those non-conformities can happen in rare cases, and these can be brought down or brought up to, or you can say that remedial action has to be taken for taking out that irregular or bad work or unacceptable work, so that it can be called conforming activity. And we only see that method statement is just a way. It's not something you can say we can fight with that. It's something that we have to agree on. Some common way of doing, which is in conformance to requirement. Common way, this means whoever are administrators on this contract, who take care of this activity, this work, those must agree in principle, and those who work on sites in front line, if you call it, those personnel should know what is going to be done, or as a duty what they have to do. That's also a very important point. If they know in advance, they feel comfortable. We have ideas what we have to do. We know what we have to do. It won't create problem, but it would make life of worker easy, efficient working on site, because they know what is to be done. They will not look faces of each other, whether work they are doing is right or not right. In a confidence building status, a degree of confidence exists on work that we know our work. Engineer remembers then, okay, I have explained to them, and they know what is to be done. So there are ways of simplifying tension, removing tension from unnecessary consideration, and if that is the case that you can remove free mind, you can use free mind for doing something else. You can move on to other activity, which is also very important way of moving to other activity. Activities can be charted out if we have completed one or there is overlap. But if you have problem in one and is the independent activity, that activity can start. But if suppose that activity is related to this one, directly or indirectly, you cannot start other activity, because until this is resolved, you cannot cannot move to work with another activity. It's very much basics. Yes, there is another area you can work in that's no issue, but in this area, you are trapped in already. Until you come out of that trap, just by removing non-conformities, you cannot move on this further work. So that's the obstacle you cause yourself. And only ways do right work. And this is what our quality requires. Pushing work is meaning not to do bad work. When we say push it, of course it's different language. Some people in field say, I want to push project. But it doesn't mean you want to push projects, means you want to move project further. But not at conformance, or you can say it's not the cost of non-conformance. If you progress up, if you push project duly non-conformed, you cannot say you've done it. Nobody shall accept your work. This means you did negative work, in fact, negative work, which is not acceptable. I would say negative work is more harmful than no work because you have spent money on materials, on other resources, and work is not accepted. There is something to be done on that if it is to be acceptable, or you have to remove all and do again. So it is, you can say, detrimental completely to your organization, financially as well as reputation wise. You cause harm to your organization as well as to your own efficiency, that this professional, this engineer does not know job, does not have experience of doing right job. Remember, ultimate liability, responsibility, obligation comes onto responsibility or shoulder of engineer in contracting, engineer in designs, engineer in administration. They all are actually responsible for non-conformance. Because why it is allowed? Why non-conformance is allowed? You cannot exclusively put blame on one, though contractor is responsible, because exclusively responsible because contractor charges for that item, and it is contractual duty, it is legal duty of contractor to take care of that item while working on that. While working on that, care has to be taken. If you don't take care of that item, it is foolishness, I should say. Foolishness on part of everyone. Contractor personnel, supervising personnel, and whosoever else are there. Because knowingly doing something is not accepted just in interest of pushing project. Sometimes they go, no problem, it's very small. They say like that, it's very small, don't worry. If it is a small mistake, why are you compounding this mistake? My worry is that. Take care. Don't be in a hurry, because when you drive hurriedly, you can cause accidents. You don't understand, maybe there is accuracy